Section 11.4. Probability is the chance that something happens. It is written as a fraction or a decimal. Probability equals success over total. How many ways success can happen divided by the total of things that can happen. Okay. As a decimal, it must be between 0 and 1. Okay. Probability has to be between 0 and 1. Now, those or equal tos in the less than symbols means include. So it includes 0 and it includes 1. It can be 0, and that means there's no chance something will happen. It can be 1, means something absolutely will happen. It cannot be more than 1. It cannot be negative. 1 is the decimal form of 100%. Okay, so let's look at this table. And we have hours of sleep on the left, and on the right, the number of Americans in millions. Okay, so 4 hours of sleep or less, that 12 means 12 million Americans said that's how much sleep they got. Okay, P parentheses A means the probability A happens. If A equals getting 6 hours of sleep, okay, we look there and we see that it says 75, okay, and we look down at the bottom, it says 300, okay, so this is called an empirical probability, means you're using past data. So the probability of somebody getting 6 hours of sleep is the 75 over the 300 total, okay, and when you divide that, it comes out to 0.25. When you reduce it, it equals 1/4. Okay, 75 goes into 75 one time, and 75 goes into 300 4 times. If you flip a coin, it can land on heads or tails, and each of those are equal chance. So the probability that it lands on heads is 1 out of 2. One side has the head on it, and there's 2 sides. A 6-sided die has the numbers 1 through 6. Each of them have an equal chance. Okay, there's an equal chance of rolling any of the numbers. The probability of rolling a 3 is 1 out of 6. There's only one side that has 3 on it, and there's 6 sides. The probability of rolling an even number, well, the even numbers are 2, 4, 6. Okay, so there's 3 numbers that are even out of the 6 numbers, and that reduces to 1/2. 3 goes into 3 one time, 3 goes into 6 2 times. Okay, what about the part C, the probability you roll a number less than 5? Well, what's less than 5? 1, 2, 3, 4. So that's 4 numbers out of the 6 numbers. And that reduces. 2 goes into 4 2 times. 2 goes into 6 3 times. Okay. D, the probability that you roll a number less than 10. Well, all the numbers are less than 10. Okay, 1 through 6, those are all less than 10. So that's 6 things that are less than 10 out of 6 sides equals 1. E, the probability a number greater than 6. Well, no numbers are more than 6 because all the numbers are just 1 through 6. Nothing's bigger than 6. So that's 0. Okay, our next example uses a 52 card deck, okay, as illustrated here. Okay, there are 52 cards. There's aces, 2 through 10, jacks, queens, and kings. Okay, there are 13 in each suit. The suits are hearts, clubs, diamonds, and spades. Okay, so the hearts and diamonds are red cards. Clubs and spades are black cards. Okay, so there's 13 hearts, 13 clubs, 13 diamonds, 13 spades. You are dealt one card from a standard 52 card deck. Okay, find the probability. The probability of a king. Hold on, I messed up my pictures. Sorry, this should be. Okay, sorry about that. Okay, so the probability of a king. There are 4 kings out of 52 cards. 4 goes into 52 13 times. 4 goes into 4 1 time. The probability of a heart. Well, there's 13 hearts, 52 cards. 13 goes into 13 1 time. 13 goes into 52 4 times. The probability of a red queen. There are 2 red queens. Okay, that's the queen of hearts and the queen of diamonds. So that's 2 out of 52, which reduces. 2 into 2 equals 1. 2 into 52 is 26. Each person carries 2 genes that are related to the absence or presence of the disease cystic fibrosis. Most Americans have 2 normal genes and are not affected by that. However, 1 in 25 Americans carry 1 normal gene and 1 defective gene. Okay? We use lowercase c to represent the defective gene, and the normal C to represent, a capital C represents the normal one. So a person with a carrier has a capital C and a lowercase c. Now, they carry it, which means they can pass it to their children, but they won't have cystic fibrosis, okay? So both capital C's are somebody who doesn't carry it and doesn't have it, okay? Capital C and lowercase c is a carrier that's not sick. They can pass it, though. That's what it means to be a carrier. Now, to have sickle cell, when somebody has sickle cell, is when they have both of the diseased genes, which is both the lowercase, okay, the defective one. Okay, so what if both parents are a carrier but they don't have it? So if both parents are a carrier, that means they have 1 normal one, the capital, and 1 lowercase, the defective. Okay, so there are the 4 possibilities of putting the 2 things together. Okay, the blue represents they got both of the normal ones. The green represents they got 1 of each, and the yellow represents they got both of the bad ones. Okay, what's the probability their child will have cystic fibrosis? Okay, well, that's the yellow where you have both of the bad ones, the lowercase. That's 1 out of the 4 choices. Okay, what about a carrier? A carrier is when you have the normal and the diseased one. Okay, and that's the green, that's 2 out of 4, which is 1/2. Okay, the blue represents you got 2 normal genes. Okay, you won't be a carrier, or their child won't be a carrier, and that's 1 out of the 4 possibilities. Okay, here's a new table. 254 million Americans ages 15 and older, and asked about their marital status. Okay, so we have married, not married, divorced, widowed, and then also by birth gender. So we have married, never married, divorced, widowed. Okay, and then we have the totals. So the yellow is the 254 total. Okay, now these represent millions. So what is the probability somebody is divorced? So look at the divorce column total. That's 26 out of the total 254. Okay, so that's about 0.10. Okay, female, look at the column on the right. The 131 represents the total females out of the total 254, which divides to about 0.52. Okay, and that's the end of this section.